Now we're looking at the calculation of the net present value and internal rate of return of a set of predicted cash flows. So in this case, we have a set of cash flows. The company's chosen discount rate is 13%, and we're going to work out whether the firm should take on the project at all given the cash flows. So the project is a 5-year project, and there's cash outflows and cash inflows. So initially, there's a cash outflow of €8,700,000. Then each period there is a cash inflow as well. So year 1, that's 1.2 million. Year 2, 2,510,000. In year 3, 3,800,000. Year 4 is 3,500,000. And while there is a cash inflow of 2,700,000 in year 5, we will also sell the factory for 2.5 million. So the total cash inflow in year 5 will be €5,200,000. The chosen discount rate, as we said, is 13%. So in this example, we're going to take the discount factors for 13% and add them to the table. Bearing in mind the discount factor in year 0 is always 1. After that, we have a series of discount factors for each year. These are just copied from the discount table and entered straight in, and then will be multiplied by the cash flows to give us a present value. So as we multiply those by the cash flows, we again, 1 by the initial figure will remain the same. The second figure will give a net cash flow of just over €1 million in year 1. In year 2, it will be just under €2 million. In year 3, it's going to be 2.8 million by 0.6931, which will give €1,940,540. For year 4, it's 3.5 million by 0.6133, and for year 5, it's 5.2 million multiplied by 0.5428. By adding the cash flow in and reducing it by the cash flow out, we get the net present value for this project. In this case, that is €1,237,153. The cash flow is positive, therefore the rule is that we would accept this project. To calculate the internal rate of return of this project, we need a second discount rate which will provide a negative cash flow for the project. In this case, we've chosen 18% as that rate. So we're going to take the cash flows again for each year, starting at year 0 and going forward. But we're going to multiply each of those cash flows by the discount factor for 18%. And so again, we need to return to the tables and get those individual discount factor figures and add them in. Multiply the discount factor by the respective cash flow again, so that we end up with a net present value calculation that we can use. And so in this case, as we multiply each one of them across and then add it up, we actually find that there is a negative cash flow of €98,012. So now we're in the situation where we have all the figures we need to actually calculate the internal rate of return. And the internal rate of return is given by a formula which starts with the positive return, which is R1 here. And to that we add the positive net present value divided by the positive net present value minus the negative net present value. And all of that multiplied by the higher percentage rate minus the lower percentage rate. And so in our example, we started off with 13%, so that's 0.13. The positive cash flow was 1,237,153, and underneath again that's added to the negative cash flow, which is 98,012. And because there's two minuses there, the minus are cancelled out and you end up with a plus. We then are going to subtract the 13% or 0.13 from the 18% or 0.18. And so we're also going to solve inside in the brackets as well. And so it's now going to be 1,237,153 divided by 1,335,165. And that's multiplied by 0.5. Dividing what's inside the square brackets into one another, we get a figure of 0.92659. Multiply that by the 0.05, given a figure of 0.0463. We now add those two figures together, and that gives us a figure of 0.1763 or 17.63%. It's important to remember that the internal rate of return is not used as a mechanism to choose between projects. It's used as a hurdle rate. That is, you either hit a set rate or you don't.